How does your body break down glucose? Let's talk about it. So we got glucose here. It's going to react with the enzyme hexokinase, but we got to spend money to make money. So this ATP over here, it's going to become ADP plus P. This phosphate here is going to get attached to the 6 carbon. Now we got glucose 6 phosphate. This glucose 6 phosphate is going to react with an enzyme called phosphoglucose isomerase, and it's going to become fructose 6 phosphate. Now this fructose 6 phosphate is going to undergo another transition through the enzyme phosphofructokinase 1. We're going to need another ATP because we're going to add this phosphate to this molecule. Now we have fructose 1,6-biphosphate. We are net 2 ATP in the whole. So this fructose 1,6-biphosphate is going to react with an enzyme called aldolase. We are going to get out of this glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. Now this, your body really wants glyceraldehyde 3-phosphate, so it's going to react with triose phosphate isomerase, and then we're going to get into step 2, or the second part of glycolysis down here, where we have 2 glyceraldehyde 3-phosphates. They're going to react with glyceraldehyde 3-phosphate dehydrogenase, and an NAD is going to come up here, and it's going to pick up a hydrogen, getting reduced, becoming NADH. And then we also have an inorganic phosphate group that's going to get added to here as well. And then this is going to create 1,3-biphosphoglycerate. Now 1,3-biphosphoglycerate is going to react with an enzyme called phosphoglycerate kinase, and it is going to become 3-phosphoglycerate. But check this out, that biphosphoglycerate molecule got broken up, so we're going to get an ATP, and we're going to get an ATP. Now we are net even for ATP down here, so let's scroll down. This 3-phosphoglycerate is going to react with phosphoglycerate mutase, becoming 2-phosphoglycerate. All I did was change the position of the carbons of that phosphate group. Now step 9 down here, this 2-phosphoglycerate, it's going to react with enolase, and it is going to become phosphoenol pyruvate. We're almost done. All right, so our phosphoenol pyruvate is going to react with pyruvate kinase, and look over here, there's no phosphate group. What happens to it? Okay, so we got an ADP over here, and it's going to take that phosphate group, becoming an ATP. ATP. So we have, for one glucose molecule, we have C6H12O6 plus 2 ATP, because remember, we got to spend money to make money. It's going to react, and then we're going to get 2 NADH plus 4 ATP plus 2 pyruvate. And that, ladies and gentlemen, is how your body breaks down glucose in glycolysis. This pyruvate, it can either go to the Krebs cycle or it can become lactic acid.